So, hello everyone. This is one of the first talks about Clutch that addresses the matters here. So please have mercy, because giving a talk about a new technology for the first time is always a bit confusing. And for the first time in about 16 years of giving talks, I managed to actually forget my computer at home. And I mean at home, and I've recognized that at the airport. So I had to get a brand new MacBook from the Apple Store. Yeah. So sometimes, I'm not sure whether you've given talks, and sometimes it's just that, I don't know, stress kicks in and also triggers procrastination with me, right? So you'd rather paint the wall than to prepare the talk. So fun fact of the day, you learn most preparing a talk, not listening to a talk. So things I've learned during my procrastination, for example, is, did you know that a pelican can actually swallow a dove entirely alive? I've seen that in a video. It's amazing. But yeah, today it's about data service management across fleets of Kubernetes clusters. And in particular, I'd like to talk a bit about the context, because as a CEO of a platform automation company, we've been automating software operations for 16 years now, and we've been doing declarative data service automation for more than 10 years now. So way before Kubernetes was as popular as it is today. And when talking to people with Kubernetes, as the Kubernetes community is a bit differently structured than, for example, the Cloud Foundry community, where we've been very active in the past decade, it's worth talking a bit about the context of this talk. So we've been working a lot with large enterprises. I say mid-sized, but a lot of them are relatively large. Some of them have hundreds of thousands of employees, and some of them have 10,000s of developers. When those organizations realize that there's a certain fear of disruption because some startups go around and break existing business models, they want to transform themselves. And a company that's very large and established, especially in Europe, I'd say, they have certain constraints, not only because of the sheer scale of the organization, but also because of labor laws. And oftentimes they sit on a tremendous amount of developers who are not used to work in a cloud-native way. So how can you enable companies like that to use progressive technology? And what is the best way to do that? And today we focus about the question on how to give a large organization that is potentially using a lot of Kubernetes clusters a meaningful way to expose data service automation to their developers. So we are talking about organizations that are likely to have hundreds of thousands of developers who will create hundreds or thousands of apps and subsequently depend on hundreds or thousands of data service instances. What we want to give those developers is the on-demand self-service. We don't want to order a new server. I mean, we're at 2024, are we? So they should have full control over their data service instances, and in a way that whenever they build an app, they should run it. They should have the operational responsibility for the app. They should have the operational responsibility for their databases. However, not to the full extent. Because in our experience, the typical persona of a developer is focused on a domain problem and application development, and they're not necessarily Kubernetes or database administration experts. So yeah, so on the right side, you see a placeholder. It gives you a lot of different data service logos. Beautiful, right? So the typical persona would be somebody with beginner or intermediate level Kubernetes knowledge, a person with strong domain knowledge and sound programming skills, but not necessarily an idea on how to run databases. They often know particularly well how to use them, So, for example, let's say finance industry, banking customer. We meet developers there who know more about using a database like Postgres than we do, although we automate databases. But they are experts, and they've been using databases like for decades, and they are very, very knowledgeable here. But the database administrators are usually not in the application development teams, nor can they be, because there's so many developers and only so many DBAs and only so many DevOps. And while becoming a DevOps is more popular and there are more people being skilled in that regard, for the typical digital transformation organization, it's not easy to recruit the necessary amount of DevOps to create truly cross-functional teams. And this has to be taken into consideration when designing automation for them. In particular, what works at scale, and this is not a hypothesis, this is something we've learned over the past decade, is you want to give the application developer the self-service, yes, but you don't want them to have the burden of operating and be responsible for the actual data service instances and its automation. So that's the difference. They give them an API that allows them to trigger lifecycle events of a database, like making it smaller, making it bigger, make a version upgrade, make a backup, restore a backup, but don't force them to deal with a split brain problem when after network segmentation and try to repair the database. Let's default them to restoring a backup or give them clustered instances that they have where they can extract the most recent version of their data. And I have a platform operations team that runs the actual automation. Because if you think about 100, 200, 300, 400 application developer teams, and they'd all be running, let's say, their Kubernetes operators along their applications, you would create the necessity that all of these teams know how to run those operators, how to upgrade the operator codes themselves, including the data services, the instances of the data service. And that's usually... I've never met a customer of a large size that wants that, except for edge scenarios where you'd have Kubernetes as the primary infrastructure abstraction. So these statements are not true in the absolute vacuum of space, but they always are true in a particular context. And so at Any9s, we have a department that runs our automation on behalf of clients. And in contrast to other companies, we do run our automation within the infrastructure accounts of our clients. So on their AWS account, on their Azure, in their Ali Cloud, on their OpenStack, on their vSphere, both on-premise and public clouds. And we have 10 full-time equivalents in that operations department, and they run 40,000 virtual machines, mostly data services. Just to give you a contrast, before declarative automation, we had around 150 to 200 instances per DevOps. Now we have about 4,000. So in my opinion, when it comes to data service automation, the game changer is not Kubernetes. It is declarative automation in conjunction with the ephemeral VM and persistent disk, or ephemeral pod and persistent volume. It's that pattern, how to do lifecycle automation, that has been the game changer. So we, for example, use BOSH, a technology known from the Cloud Foundry ecosystem that allows you to do declarative management with virtual machines, and it scales to that scale that I've just mentioned. We've seen statements about, at this very conference, about whether it is a good idea to run data on Kubernetes. And just to give a comment on that, I don't particularly think that Kubernetes is a bad place to run data services. I think there are some issues, like noisy neighborhood issues with a lightweight container virtualization in contrast to more solid para-virtualized VMs. However, if you, for example, want to create a lot of cheap service instances, the decreased overhead of a pod compared to a VM will save you a quarter of a gig, half a gig per service instance, which, if you have a lot of relatively unimportant databases to run, can actually make a pretty good business case. But the compelling point, and the main point where I understand the criticism of patterns I see in adoption of Kubernetes operators, is that for most organizations that run a lot of Kubernetes clusters, it's not a good idea to run the data services the operators and the instances along the applications, because that creates that problem I tried to explain earlier, that you don't have that separation of responsibility. So how can you address the problem of taking away the burden of operating the automation, but yet enabling application developers to use Kubernetes-native YAML specs, talking to their local application developers, and have that cohesive Kubernetes experience without running into that trap I've just mentioned? And by the way, this needs to run across all major infrastructures in both multi-cloud and hybrid cloud scenarios. And if you think about, well, where do databases come from? Well, some people would say, well, we want to use operators. Others would say, give me something else, like BOSH-based automation. Or I will consume it from the infrastructure provider. And in my experience, this strategy will change over time. So some people say, well, we are Amazon all in. And they usually bounce back from having one vendor for something essential as those resources, and eventually bounce to a multi-cloud strategy, for example. So allowing people to change their strategies over time would also be nice. And thus, it would be nice to be able to integrate all automation backends that actually do the trick. So we thought about this problem. We started to think about this problem within the context of our own commercial automation backends, but then slowly discovered that it's actually a problem that's way beyond our products, and it is a problem that is quite dominant in the Kubernetes ecosystem. So if you followed the cloud automation and the container orchestration wars, I don't like this term, but this was how it was referred to a few years ago, there was a decline in the public perception of Cloud Foundry, and there was, Kubernetes is the winner and we'll take it all. Funnily, our Cloud Foundry business is growing to this day. And one of the reasons why this is the case is because if you're building large developer platforms, there are unsolved problems if you use vanilla Kubernetes. And even onboarding components from the CNCF ecosystem, for example, will not solve all of your challenges. So we've introduced or we created the technology that we would like to share with the community. It's called Clutch. Logo and colors still in the making. And it is published under Apache license. So it's open source. You can give it a try. You can adapt it to your own purposes. We don't want to keep it for ourselves. It's for the community and it's to share. So what does it actually do? Well, first of all, it provides you, as the application developer, with Kubernetes-native resources, CRDs, right? So any data service that is exposed through Clutch will be represented using CRDs. And I will talk about the abstractions Clutch provides to make it simple to consume data services. But it's important that as the application developer, all you'll do is you'll create your local Kubernetes cluster, and you don't have to take care where the actual magic is happening. The interface is so unified that once you've learned how to use one data service, you'll be easily using other data services. Like, you know how to use Postgres, you can use MongoDB. And if you use one Postgres, you can easily use a different implementation of a Postgres provided by some other automation backend. For the part that integrates external systems that utilize Kubernetes as the domain language, but are not automated within Kubernetes, we leverage Crossplane. But we build on top many other abstractions that differentiate us from Crossplane quite intensely. And the idea is that you have a large number of Kubernetes clusters. So, well, think of the number of Kubernetes clusters are growing. You don't know how many there are, but there will be many of them. Then you have Clutch in the middle as a central control plane that also is a Kubernetes workload, and then integrates with any automation backend, which could be a Kubernetes workload, but doesn't have to be. So you could talk to, let's say, automation backends that we provide at Anyninds, or you could provide You could integrate Azure or AWS-based services, however you like. So it's hard to get that, and we're still discovering how to, speak to an audience like yourselves and find the right ways to talk to it. That's the point where I really need your mercy a bit, because we don't know the right terms yet. We don't know how the visuals should look like, but this is the idea that you have an environment where there are many Kubernetes clusters, and you establish a control plane on a Kubernetes cluster that comes with a clutch extension, with the clutch server, and you install in every consumer cluster a lightweight extension, the clutch client. And what is the clutch client? It's just a set of operators that provide you with CRDs that remote control the actual data service instances, the service bindings, and gives you abstractions to create and trigger backup and restore events. So once you've installed the clutch client to your cluster, all the automation backends that you configured will appear in the consumer cluster. And as a developer in a team, you will be able to create service instances as if they were local. But they're actually not. And now this architecture has some contrast to other attempts to solve this problem, where most likely you'd see a connection between the consumer cluster and the automation backends directly. Well, you could place the control plane, let's say cross-plane in the middle, but in the end, you would have to install it in every consumer cluster. And what we want at a large organization is, for example, to enable a central registry where there's knowledge about where do service instances exist and what's the state of that service instance at any given moment. So why would you do that? Just imagine there's a new Postgres vulnerability, it's highly critical, and you're running an insurance or a bank. Surely you'd like to know, well, where are service instances of that particular versions, and you want to ensure that the application teams do a good job and upgrade those services, which they usually can't do because you have awesome automation. But you need to ensure that this is actually happening. And this is exactly where this centralized metadata registry that Clutch provides you with comes into play and helps to solve problems with governance. But more than that, think about the infrastructure deployment of such a thing, where the Kubernetes consumer clusters could be spread across different AWS clients, for example, different AWS accounts, where the automation backends would be in different AWS accounts, and that you'd have to do some dynamic network configuration and keeping those configurations up to date whenever clusters change or data services change. For example, an upgrade will likely trigger to create service instances new IPs because their VMs are being recreated. So then you need a dynamic component that observes both sides of the automation, the cluster side, the application side, and the data service automation backend side, and triggers dynamically network configuration and firewall configuration. Well, this is not implemented yet in Clutch, but this is where Clutch is headed. If you want to remote control a data service from your consumer cluster, there must be something that somehow tells the Clutch server what you want, and then make the Clutch server delegate that heavy lifting to the automation backend. And this is for the service instance one thing. You want the Clutch server to know about the service instance at all times, so you need a replication of that declaration that you uttered against the local cluster, and you need to replicate that to the Clutch server. This is exactly what ClutchBind does, which is inspired by KubeBind, but will be modified in the process to meet our very specific demands. And for example, once you've created the service instance, you also want to connect to a database. So the abstraction in Clutch, therefore, would be a service binding, which creates a database user, and also allows you to create a secret in your local Kubernetes cluster. So you can imagine what needs to happen between the server and the local cluster. You need to synchronize information about the secret and transfer those pieces of information in an encrypted way. So all these things are handled for you. And if you dive deeper into that architectural diagram earlier, you will see something like this here, demonstrating the use case of creating a service instance, but it's similar for service bindings and backups or performing a restore. So the application developer here would interact with their Kubernetes cluster, would talk to the Clutch client by creating a custom resource based on one of those proxy CRDs. Here, the service instance proxy CRD, which will talk to the Clutch server, create the service instance there, which will trigger the automation backend and do the actual heavy lifting there. So in this case, I'm just unpacking our service broker. It's not to advertise this. You could use anything else. But just to give you an idea, in this case, you'd be actually creating virtual machines. Or in the picture below, you'd be using an open source or any other operator for that matter and creating pods, or talk to AWS APIs and create an Amazon RDS instance. So, as I said, this provides you with the convenience of the application developer. And in this scenario, the platform operators could run, for example, the data service automation in the upper right, or if you consume AWS resources, that operational effort would dissolve into paying more per instance. And because we are using Kubernetes workloads, we're not making any assumptions about infrastructures. And as long as your automation backends are infrastructure agnostic, your whole system will be. And I will show you some examples how the YAML specs will look like so that you can see how much of abstraction you'll get from Clutch and how this makes consuming data service charmingly easy. So the first abstraction that comes with Clutch is a service plan. So in contrast to having an operator where you have a relatively mighty and flexible spec that you can address individual configuration items to the very great detail, this is usually for application developers, let's say, it depends on their maturity, depends on how much they know about the database, but our experience shows that many times pre-configured service plans, configurations that resemble well-known use cases where the size and the data service configuration is well tested, works the best. And that's the service plan. You can, let's say, give me a Postgres with asynchronous replication and 16 gigs of memory and an appropriate amount of storage with it. That would be based on a service plan. And the way you'd be using such a service plan is just creating this piece of YAML spec. Of course, if you want to add more details, the spec becomes more complicated, but it's basically as simple as that. You specify the service, you specify, in this case, it's AWS Postgres as the automation backend. But if you don't want a pods because you believe that data servers don't belong into Kubernetes, well then, there you go. And just create the any9's Postgres, which creates virtual machines. Or if implemented, we are currently doing that, Amazon RDS to create an RDS instance. And you will see that because there's so little change between the two implementations of Postgres, this also protects your investment as the application developer into your CI/CD pipelining and also into your own knowledge, because you don't have to learn the structure for every data service. At least for the average case, you'll be fine with a relatively abstract structure like this. So once you know one data service, you basically know them all. But creating a MongoDB instance is as simple as that. Yeah, it's the service plan that hides the details on what is the particular configuration of the MongoDB. And there will be service plans or the ability to parameterize service instances if you really want flexibility. But in most of the cases, if you just want to spin up let's say, a cheap MongoDB for testing purposes, this will do the trick. Or Amazon S3 buckets for that matter. But once you've created the service instance and you want to use it, you still need to have, grant access to a database. And this process is encapsulated as a service binding, which is an abstraction that all these abstractions, except of backup and restore, originate from the Open Service Broker API, which was a REST-based standard. And we translate this into imperative Kubernetes idiomatic format. So the service binding will create a database user and a Kubernetes secret. So all you have to do is deploy your app and reference that secret to use the database. And just be reminded, the data service instance will not run in your Kubernetes cluster. It will run someplace else. But the central control plane of Clutch will know where it is. It will know about which cluster asked for it, which data service instance, in which particular version, in which particular declared state there is. So backup and restore, don't have an example ready for you, but it's a similar YAML file that will reference the service instance and restore, referencing the backup in a similar way. Clutch can be extended. It's actually waiting for your touch to extend, Clutch with adding your automation backend. So you can use Clutch to expose internal services that you create within your organization to your Kubernetes users, or add data service backends if you're a provider of data service automation. So where is this headed? The basic idea is to make Kubernetes work in large-scale environments where there are a lot of Kubernetes clusters, a lot of application developers, and make the enterprise-ready check marks, which is so hard to do with just Kubernetes as it is right now. So if you want to get involved, we have a booth. You can see demos, and we'll talk about the technology and more of the guts of Clutch if you'd like. There are ways to get in touch. Clutch.io, there's a demo that you can download on your laptop and make experiments with it. And there's a Slack channel that you can, if you choose to talk to us later. Well, that's the basic idea of Clutch. I hope you see some value in there. And if there are questions, I'm ready right now.
Let's have a round of applause for Julian. I really enjoyed your presentation, and I like how you started with the personas, like the way you think about who's going to use this thing, and I'm sure that's really reflected in the developer experience and in your quest to make everything easier. So yeah, remember to submit questions, everyone. But I've got one while people are writing things. So you're using Clutch right now at NE9s. What's the biggest environment and challenges that you're solving with it right now?
So in particular, it's organizations that run Cloud Foundry. They are per se big because you don't pick up Cloud Foundry if you're not big. And if you extend the usage to Kubernetes, you run into all these problems we mentioned here. And this is the kind of enablement we do with Clutch at the moment. It's like help those clients to adapt Kubernetes in a more meaningful way while keeping the operational efficiency that they are used from Cloud Foundry. And
you showed like Azure, AWS. Can you use this like in your own private data centers? How could you like make it work if you're on-prem?
Yeah, Clutch itself is a Kubernetes workload, so you can run it everywhere Kubernetes runs. And it just depends on what data service automation backends you have integrated with Clutch. So anything that gives you data service will work. You can use any open source operator, for example, make a dedicated Kubernetes cluster to create service instances there, and then use Clutch to expose that to a number of consumer clusters.
And what's next for Clutch? Like looking at what you're going to develop, what's the next feature that you're most excited about?
It's integration of automation backends mostly. We're currently working on AWS, and then we'd like to see some contributions from the community helping us to, because it's heavy lifting. There are a lot of cloud services out there who want to be integrated, and also the framework itself needs some love, but that's making Clutch more mature and integrating more automation backends.
We have one question, and it's, can Clutch be an optimal solution for bringing several databases under the same room in a single Kubernetes cluster? Like bringing multiple databases together.
Yeah, I mean, that's one of the purposes of it. So if you have Redis, MongoDB, Postgres, and you want to expose them all to a Kubernetes cluster, well, Clutch can help you with that. However, where Clutch is strongest is if you have multiple Kubernetes clusters, because if you only have one and you're sworn never to have more than, let's say, 4 or 5, then maybe there's overhead to Clutch that doesn't make sense. But whenever you want to have that separation of concerns in your team, where there's a platform operator team, and you want to have that central overview, then Clutch is for you.
And there's one more. Can we import existing databases into Clutch?
Well, yeah, it's not impossible, especially if you run on AWS. It's about creating metadata accordingly. I think we haven't done this yet, but I think it's technically possible. Whether it's financially meaningful is a different thing. I don't have an estimate about this yet.
Okay, last chance for questions. Let's give one more round of applause to Julian.
Thank you.